Good morning. Today we will learn about evolution of microprocessors. Last class we had discussed about microprocessors, microcontrollers, microcomputers, and what is a microprocessor? Microprocessor is a electronic device that accepts input and processes the received data and produces the output according to the instruction given to that. This is microprocessor. So, in short, we can microprocessor called as a MUPI. And what are the application of a microprocessor? If it requires in a fan or a tube light, no, it's not required in a tube light or a fan, but microprocessor requires in mobile phones, computers, remote controllers, etc. Then what is the difference between microprocessor used in a computer or a mobile phone, but it is not in a fan or tube light? Why? In a tube light operation, if we want to switch on or off that light, we just put on the switch on and off stage. That is, there is no internal program is running inside that fan of working of a fan or a tube light. So, but in a computer or a mobile phone or a remote control, there are internal some program is running. So, wherever a program is involved, or if we need to do a program that requires processor. So, all the programs written in that device is executed by this processor. For example, a traffic light control. In a traffic light controller, there is a internal program or an algorithm running in that. What is that algorithm? First, show the red light and wait for some times. Then show the green light, wait for some times, and show the yellow light and wait for some times. And all this put into a loop. That is the algorithm running like that. So, in that case, we require a MUPI. So, massive use of microprocessor is mainly in computers. So, we require microprocessor. That is the basic idea behind this microprocessor. And the microprocessors are introduced by mainly the manufacturer who is introduced this microprocessor is Intel. Most of the microprocessor is manufactured by the Intel, and there are different types of microprocessors are there: 4-bit, 8-bit, 16-bit, 32-bit, and 64-bit microprocessors. What is meant by a 4-bit microprocessor? 4-bit microprocessor means at a time it can process 4-bit data. So we will look at through the evolution of microprocessor or history of microprocessor. Then first microprocessor is a 4-bit microprocessor. It is Intel 404 that was introduced in 1971, introduced by Intel, and it was the first microprocessor by the Intel, and it is a 4-bit MUPI, and its clock speed was 740 kilohertz per second, and it consists of 203. It had a 2,300 transistors, and it could execute around 60,000 instructions per second. So it is the first commercially available microprocessors, and originally it's designed to be used in Visicom calculators. Then next is Intel 4040. Is introduced in 1974. It was also a 4-bit microprocessor, and here interrupt features were available. You had a 3000 transistors and same clock frequency as that of for Intel 4090, and has a 640 bytes of data memory. Then next is a 8-bit processors. There are only two 4-bit processors, and next generation is 8-bit processors. First one is Intel A008, introduced in 1972, and it was the first 8-bit microprocessor, and the clock speed was 500 kilohertz, and is can execute 50,000 instructions per second, and it had 3,500 transistors, and it can addressable memory is 16 kilobytes, and it is mainly used in early 8-bit microcomputers, dumb terminals, and general calculators, etc. The next 8-bit microprocessor is Intel A080A, and it is introduced in 1974. It was an 8-bit microprocessor, and clock speed was 2 megahertz, and it is 10 times faster than 8008, and it had 6,000 transistors, and it can execute 5 lakh instructions per second, and available memory is 64 kilobytes of memory. Here data bus width is 8 bits and address bus is 16 bits, and it's mainly used in traffic light controllers and cruise missiles. Next microprocessor is A085, and introduced in 1976, and clock rate is 3 megahertz, and data bus size is 8 bits and address bus size is 16 bits. So we can how many memory location can be accessible? It is a 16 bit, so 2 raised to 16 kilobytes memory can be accessible, that is 64 kilobytes of memory can be accessible, and it had a 6,500 transistors, and it can execute above 7 lakh instructions per second, and it had an instruction. How many instructions are there? 246 instructions are there, and it is mainly used in computer peripheral controllers such as modem, hard disk, printers, etc. use Intel A085. Next one is Intel A086. Is introduced in 1978, and it was the first 16-bit microprocessors, and its clock speed is 4.77 megahertz, 8 megahertz, and 10 megahertz, is depending on the version we are used, and the data bus size is 16-bit and address bus is 20-bit. That means it can carry 16-bit data and it can carry 20-bit address, and it had 29,000 transistors and execute how many instructions per second? 2.5 million instructions per second. If the address size is 20 bits, so how many memory can be addressable? 2 raised to 20, that is equivalent to 1 megabytes of memory. That is 2 raised to 20 we can written as 2 raised to 10 into 2 raised to 10. That is 2 raised to 10 is 1 kilobytes of memory. So 1 kilobytes into 1 kilobytes, that is 1 megabytes of memory. So it had how many instructions are there? 22,000 instructions are there, and it can use multiply and divide instruction. What is meant by multiply and divide instruction? For multiplication and division, we are separate instructions are available in A086. But in A085, if we want to multiply, we are using repeated addition. For division, we are using repeated subtraction. So, but in A086, there is a separate multiply and divide instructions are available. Then Intel A088. It is introduced in 1976. It was also 16-bit microprocessors, and it was created a cheaper version of Intel A086, and it was a 16-bit microprocessor with external bus size is 8-bit, and it can execute 2.5 million instructions per second, and it is most popular in the computer industry, and when IBM used it for its first PC. So which one is the first PC used IBM? That is Intel A088. Then next one is 16-bit processors. First one is Intel 80186 and 80188. It is introduced in 1982 and there were 16-bit microprocessors. Clock speed is 6 megahertz and data bus is 16-bit, address bus is 20 bits, so it can be addressable 2 raised to 20 bits, that is 1 megabytes of memory. And it had how many transistors? 55,000 transistors. And 80188 is cheaper version of 80186 with an 8-bit external data bus, and it include interrupt controller, clock generator, local bus controller and counters. The next one is mainly 80186 is used in embedded applications. Next, Intel 80286, which is also a 16-bit processor introduced in 1982 and clock rate is 8 megahertz and its address bus is 24-bit and data bus is 16-bit, so it can addressable 2 raised to 24 memory location, that is 16 megabytes of memory. And it had an 134,000 transistors and it can execute 4 million instructions per second. Then what are the main application of 80286 is mainly used in IBM PC 80 and it's so added feature like protected mode. Protection is included in this 80286. And next one is Intel 80386 is also introduced in 1986 and first 32-bit microprocessor and its data bus is 32-bit and address bus is 32-bit and it could address 4 gigabytes of memory, that is 2 raised to 32-bit. 2 raised to 32-bit can be written as 2 raised to 32 means 2 raised to 10 plus 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 2, that is 32. So 2 raised to 10 means 1 kilobytes of memory. 1 kilobytes. So 2 raised to 10 1 kilobytes, 2 raised to 10 1 kilobytes, 2 raised to 10 1 kilobytes. So 1 kilobytes means here total 2 raised to 1 kilobytes into 2 raised to 10, 1 kilobytes into 1 kilobytes 1 megabytes, then into 2 raised to 10 is 1 kilobytes again into 1 kilobytes, that is 2 raised to 30, that is 1 gigabytes. Here 2 raised to 2, that is 2 raised to 2 is 4. So total 4 gigabytes of memory and it had an transistors 2 raised to 75,000 and clock speed is ranges from 16 megahertz to 33 megahertz. It's depending on the version. There are different versions are DX, SX and SL and it is the best selling microprocessor in the history. Mainly it is used in entry level desktop and portable computing, and 80386 DX is used in desktop computing. And next one is Intel 486. So next 80386EX is that used in NASA's flight Linux projects, and is also 386EX is used in abroad several orbiting satellites and microsatellites. Next one is Intel 80486 is also a 32-bit processor and is introduced in 1986. It has 1.2 million transistors and varied from 16 megahertz to 100 megahertz, and different versions are there. And here cache memory is introduced. So is cache memory size is 8 kilobytes and mainly is used in Intel 80486 SL is used in notebook computers and DX is used in desktop computing and servers. And next one is Intel Pentium. It is also in 32-bit processors, introduced in 1993, and Pentium processor is original name is 80586 After 80586, it is known as Pentium. And clock speed was 66 megahertz, and data bus is 32-bit, address bus is 32-bit, so it can accessible memory location is 4 gigahertz of memory, and it can execute 110 million instruction per second. And here separate cache memory for instruction and data size is 8 kilobytes. Then Intel Pentium Pro is introduced in 1995, also a 32-bit processor. Here we are using L2 caches, and its size is 256 KB, and it had 21 million transistors and mainly used in server systems. So here separate cache is there, L1 cache and L2 cache is there. L1 cache is 2 type for instruction and for data, and each size is 8 kilobytes, and L2 cache size is 256 KB. The next one is Intel Pentium 2, is also a 32-bit microprocessor introduced in 1997. Clock speed ranges from 233 MHz to 500 MHz. Is executed 333 million instruction per second. Here it uses MMX technology. MMX technology means multimedia extension, mainly used to handle the video, audio and multimedia applications. Here also L2 cache and processor were on one circuit. Next is Intel Pentium 2 Xeon, is introduced in 1998. It's also a 32-bit processor, mainly designed for servers, and clock speed is 400 MHz to 450 MHz. And there are 2 caches are also there. L1 cache size is 32-bit kilobytes. L2 cache it a different size, 512 KB, 1 MB or 2 MB. It could work with 4 Xeons in same system. So next is Pentium 3, that is 32-bit processor, and introduced in 1999, and clock speed varies from 500 MHz to 1.4 GHz, and it had a 9.5 million transistors. So Intel Pentium 4 is introduced in 2000, 32-bit microprocessor, and clock speed ranges from 1.3 GHz to 3.8 GHz, and it has 2 cache, L1 cache of size 32 kilobytes, L2 cache 256 kilobytes, and it had 42 million transistors, and all internal connections were made from aluminum to copper. And dual core, Intel dual core, it is either 32-bit or a 64-bit microprocessor, is introduced in 2006, and dual core means it has 2 cores, and both cores are on internal bus and L1 cache. Here it shows 2 cores, CPU cores are there. Each core has its own L1 cache, but it shares L2 cache and the external bus. And it's support simultaneously multi-threading. Multi-threading means more than one task can be executed simultaneously. And one of the example is Adobe Photoshop supported SMT. Then next is Intel Core 2, introduced in 2006, and it is a 64 microprocessor. Clock speed ranges from 1.2 GHz to 3 GHz, and it has 291 million transistors, and its 2 caches are there, each cache L1 cache per core, and its size is 64 kilobytes. L2 cache is 4 megabyte size. It is has launched in 3 different versions: Intel Core 2 Duo, 2 Quad, 2 Extreme. And next is Core i7, that is a 64-bit process introduced in 2008, and 4 physical cores are there, and clock speed is ranges from 2.66 GHz to 3.33 GHz. It had 781 million transistors, and cache L1 cache has a size 64 kilobytes and L2 cache has a size 256 kilobytes. Here extra there is a third cache, L3 cache. It has a size of 8 MB. Then next is Core i5 Intel. It introduced in 2009. 64-bit microprocessor is consists of 4 physical cores. Clock speed ranges from 2.40 GHz to 3.6 GHz. It had a 781 million transistors, and there are also a 3 cache memories of the L1 cache size is 64 kilobytes, L2 cache is 256 kilobyte, and L3 cache is 8 MB. And i3, Core i3, that is introduced in 2010, and it is a 64-bit microprocessor, and it has only 2 physical cores. Its clock speed ranges from 2.93 GHz to 3.3 GHz, and it has 781 million transistors, and there are also 3 caches are there. L1 cache is 64 kilobytes, L2 cache 512 kilobytes, and L3 cache is 4 megabytes. And last one is 64-bit processor, Intel Core i9-9880H processor. Here H means high performance graphics. Here it is a 16 megabits Intel Smart Cache. 8 cores are there, 16 threads are there, and 4.80 gigahertz max turbo frequency is there. It is the 9th generation processor. So these are all about the Intel microprocessors. There are different other microprocessors are there, AMD or Motorola, etc. So you should prepare a note for that, and that's all. Thank you.